time ago I was watching this video of a guy solving a Rubik's Cube so quickly that it got me thinking, can we create a Rubik's Cube in Blender using only geometry nodes? Well, I'm happy to say that yes, we can, and let me now show you how to actually do that. So to get started, we're going to start off by clicking on the cube and create a new geometry node for it, of course. However, just for the sake of it, we're going to remove the original cube by removing the group input, and we're going to add in a cube node so that we're adding in another cube. However, this cube, we want to subdivide that one time. So in order to do that, we're actually going to make the vertices X, Y, Z over here. We're going to make that 3. However, at the moment, we cannot really see that we have subdivided our cube. So in order to see that better, we can go over here into the overlays and turn on wireframe. So in order to actually make this look like a Rubik's Cube, that's actually not so hard because we only need to instance cubes on each point of the original cube. So we do an instance on points node together with another cube node. And if you connect that with the instance like this and you make the scaling a little bit lower, just like this, then you see we have cubes stacked on top of each other and it kind of looks like a Rubik's Cube. Of course, we could say, okay, we're done. This is our Rubik's Cube, but that's not what we are here for today. Our goal is to actually create a working Rubik's Cube. So let's actually get started with that. So basically what we want to do for this is we want to make a system that allows us to rotate certain sides of the Rubik's Cube. But before we do that, we're first going to make sure that we can actually rotate one side before we can rotate everything else. So in order to rotate only that side, we're going to need a rotate instances node. So if you connect that over here, now if I rotate it over the Z-axis, you see the cubes are rotating around their local axis and not around the global axis. But we want the global axis, so we're going to turn off local space over here. And then if you rotate it, you see it rotates in the right way. However, we want that this rotate instance node only affects the rotation of the top layer of the Rubik's Cube. And to be able to select what part of the cube is affected by this node, we need to have points on each side of the cube that can rotate. And those points we can then select, and that way we can select what side we want to rotate. So in order to select those points, we first need to create those points. And we're going to create those with another cube. So if we take this cube node and we do Shift D over here and we connect it with the group output for now, then what we want to do is we want to take each face and we want to convert it into a mesh with a mesh to points node. And we set this, of course, to faces. And now we have for each side of the Rubik's Cube a point. And now we want to have the position of this point, because with that position, we are going to be able to select the right layer of the Rubik's Cube. And to get the position of this point, we're going to need a sample index node. And of course, you set float to vector because the position is a vector. And then if you do a position node, we are going to select the position of that certain point. However, we see we have index 0 over here. So now we are choosing the position of the point with index 0. However, the point that we want to have is probably not index 0. Let's actually figure that out, what index it should be. So if we do an index node, and then if you do Ctrl Shift click on this node and Ctrl Shift click on the index node, then you see the index of each point is displayed on it. However, it's displayed in a color and we don't want that. We want it to be displayed as a number. So if you go over here in the overlays, you will see under viewer node, you can turn on attribute text and then we have the index per point. We see we are going to need index 2. So let's do index 2 for now. However, in order to make it that we don't have to go back to this viewer node every single time, let's write down those indices next to the points. So if we go into side view numpad 1 and you write down 2 over here, and we can write down 5 over there, and let's write down 0 over there and 4 over there. Then let's go numpad 3 to go into this side view, and let's write down 1 and let's write down 3 like this. And now we always have, even if we don't do this, we always have the index of each side. Okay, let's go back to our Rubik's Cube. And then you see, okay, we're still not selecting the specific part, of course. However, in order to do that, what we want to do is we want to take the Z position of each cube. And if the Z position is the same as the Z position of this second index, then it should rotate by this rotate instances node. So in order to do that, we want to do a separate XYZ node, connect it like this, and now we have the Z location of that point. And to get the Z location of each cube, we can take this position node, shift D it to over here, also take this separate XYZ, connect it, and then we also have the Z location of that. And now to compare these, we're going to use a compare node, of course, set to equal, because we want to say, okay, if the Z axis of the point is the same as the Z axis of each cube, then it should be affected by the rotate instances node. And then you will see, if you put it like this, then you see that works perfectly fine. Okay, cool. Now we have it for side 2. Let's also do it for side 5. So what we're going to do is we're going to make a little bit more space. So if we disconnect it over here and we select all these nodes, shift D it to over here, and then we connect it like this and like so. Now, if we rotate this one, it does the exact same thing, of course. But what we want is side 5. So let's set the index on 5. And this part should not rotate around the Z axis, of course. It should rotate around the X axis. So let's replace the Z axis over here with the X axis. And then if you rotate over the X axis, you see that works perfectly fine. This is really cool because now if I rotate this one, for example, over the Z axis and then this one over the X axis, you see that works perfectly fine. However, there's a problem because what if we do it reversed? What if we first move this one? Well, then this will happen. So if we first move this part 90 degrees and then this part, you will see it's glitching a little bit. And the reason why it is doing this is because it's kind of impossible to make this work. Because you see, these nodes are always going in a certain order. Geometry nodes always wants to put this node first and then it wants to do this node. However, we don't want that. We want that sometimes we want to start switching this one and then this one. And the solution to this is going to be simulation nodes. However, if we are going to use simulation nodes, we are going to make sure to make it first work with one axis before we're going to implement multiple axes. So if we remove this first and then disconnect it over here, we can do a simulation zone, connect that like so and like so and like so, and then let's put the instances into the simulation. Now you will see if I press play and I change the Z axis, it will always keep on moving, and that's not what we want. What we want is that this part of the cube should only move if we change the value of the Z-axis over here. And in order to do this, we are going to need a little bit more data, so to say. So the data that we want to capture over time each frame is what is the old rotation of the part of the cube and what is the new rotation of the part of the cube. And then as a third thing, we want to calculate what is the difference between those two so that we know how much it should rotate. So if there is no difference between the old rotation and the new rotation, then the difference is 0, so it should not rotate. But if there is a difference between the new and old rotation, then it will rotate. So let's set this up. And the first thing that we want to do is add in a store named attribute node. And let's set the name on new underscore rotation or something like that. And also we are not calculating the rotation of a point. We are calculating the rotation of an instance because these cubes are still instances on a actual cube. So, okay, now we have the new rotation. Let's do the old rotation. So let's do Shift D and put that over here. And let's name this old underscore rod. And the difference between the new and old rotation, we want to calculate that in the middle over here. So if you put that over here and set this on diff from difference, then we can get started with calculating things. So the new rotation, we can keep the value as it is for now. The old rotation should always update to the new rotation. So we're going to do a named attribute node set to new rotation. And then if you put that over here, that's perfect. Now we're updating the old rotation always. So the difference should be the new rotation subtracted by the old rotation. So if we take this named attribute node, Shift D it over here, and then do another named attribute node, which we set on old rod, we can do a math node set to subtract, and then subtract these from each other, and then connect it with difference. Okay, now what we want is that this difference value value is driving the z-axis over here. And in order to get control over this single z-axis, what we need to do is combine XYZ node right over here. And then this z-axis over here should be the difference of the new and old rotation. And now if we press play, let's see what that looks like. Okay, yeah, that looks perfect, right? If we change it, it's rotating along. And if we don't change it, it stops. However, you will see that if we leave the new rotation as this value, that we are going to have a hard time to perfectly match up the cube with the other cubes, right? And that's because this is a continuous number. However, we kind of want that this value goes stepwise and not continuously. And in order to do this, we are going to make use of a map range node. And the reason why we are going to use a map range node is because we're going to map some range. And the range that we are going to remap is going to be this circle range. So in mathematics, what we say is that a circle goes from 0 to 2 pi. So we want that this map range value maps the numerical range of this circle to 0 to 2 pi. So we want 2 min to be 0 and 2 max to be 2 times pi. And now I have a cool trick, because if you now set the from max on 32, for example, then you will see if you make this value a value of the table of 8. I don't know if you say in English the table of 8. I literally translated that from the Dutch language. But if it's called something else in English, I would say comment it down below. We all learned something new today. So you will see if you make this value 8, it's perfectly matching up with the rest. If you make this value 16, it's also perfectly matching up. So you will see with the table of 8, like 8, 16, 24, and 32, it's always matching up with this thing. And now to make it go in steps, you can drag this value and hold down Control, and then you will see you will always be able to match it up with one other side. You will see though that if I go higher than 32, that it stops working. That's because this value doesn't want to go higher than 32. In order to make it that we can go even further than 32, just uncheck this clamp button over here, and then you can always go further. And that's perfect. But I will set this back on 0 for now. By the way, do you sometimes work in geometry nodes and you're thinking, oh my god, I have no idea what I'm looking at. How am I ever going to learn this? I wish there was some tool that just explains to me every single node in geometry nodes in one place in a very easy and chill way. Well, then I have good news for you, because I released the Big Notebook. It's a book that explains every single node in geometry nodes in a very easy and clear way. It starts from the very basics of geometry nodes and slowly progresses towards more advanced techniques. The book is available on my Gumroad, and it has been fully upgraded to Blender 4.3, so every new node has been added in. And you know what? It's the first month of the year, so let's do a little discount. So if you use the code CUBE, you will get 25% off of your purchase. This discount code is valid until the 1st of February, so be sure to get your copy of the Big Notebook today. And with that being said, let's continue the tutorial. Okay, let's quickly organize it a little bit better. So let's put this over here and let's put it all a little bit closer together. Yeah, something like that. Okay, the system that we have now only works for the cubes that are on the top layer of the Rubik's Cube. However, we want to make this work for every side of the cube. So in order to do that in the easiest way possible, what we're going to do is we're going to take all of these nodes and we're going to press Ctrl G to group them. And now if you press Tab, you can go out of this, and then you will see we have a little group over here. And now we can actually make it a little bit more compact, something like this. And this group is now controlling the cubes of the second index. We want to have some control variables for this node group. So if you press Tab to go into this node group, we want to have control over some stuff. So the first thing that we want to have control over is, of course, which side should the node group affect. And we're going to do that by taking this sample index and connect it over here with the group input. And now if you press Tab to go out of this, you'll see we have control over here of which side it is doing. However, we also want to have control over the actual rotation of the side. So if we go back, then we can put the group input into this value node of the map range. And now you will see we have control over it, which is perfect. So now we have the node group with the control variables. If you want to rename those variables, you can go into the node group, click on the group input, and then press N to make this sidebar open up. And then over here, you can rename this to side index or something like that. And this you can change to rotation value. So let's press N to make that go away. And then you will see it's easier to see what these values actually mean. We want to have a node group for each side. So we want to have 6 of them. So if we do Shift D to duplicate it, then again and again and again and again, then we have 6 of them. And now let's change all these side indices. So let's make this one 0 and this one 1. This one can stay on 2. Let's make this 3, 4, and 5. Okay, now if we press play and we test it out, you will see there's something going wrong, right? 2 things are going wrong. First of all, it's always rotating again, which is not really good. Second of all, it's not rotating the right layers, as you can see. Let's first fix that it's not always rotating again. The reason why it's always rotating is because each node group that you see over here is using the same new rotation value and also the same old rotation and the same difference value. However, we want that each node group has a unique name for each of these variables. And in order to do this, I'm actually quite excited about this because we're going to use nodes that I've never used in any of my tutorials, which are string nodes. So to use string nodes, what we're going to do first is we add in a string like this, and let's name this new rod. So this string value should be different for each group. So for example, what we want is that this group should have new rod 0, or this one should have new rod 1, or this one 2, and this one 3, etc. And in order to make that happen, we can do a join strings node, put that over here, and now we want to take this index and put that over there. However, you will see that doesn't work. That's because this is now an integer and not a text yet. And in order to convert this integer to a string, we can do a value to string node, set it on integer and connect it like this, and then connect it over here. And now, although you cannot really see it, it is making it new rod 0 in this case. We do have to connect it over here, of course. This we want to do the same for div and old rod. So let's make a little bit more space like so. And now we can take these 2 nodes, Shift D them to over here, connect the integer also over here, and also rename this to div. And then you can put it over here. And let's do the same for the old rotation. So if we do old rod, we can connect the integer over there and then also connect it with old rod. However, we of course also need to connect these outputs with the named attribute nodes, otherwise it's not going to work. So if we connect this join string with the new rotation, and then let's also connect it over here with the new rotation, and then let's connect the old rotation with the old rotation over here. Now the only thing we need to do is connect this one with the div. So if we do div right over there, then it should work and it should not always move anymore. So you will see that works perfectly fine. And you will also see that that works for every single one of them. However, now we have the second problem, which is that the axis of the indices are not good. So for example, this group 4 should rotate these cubes over the x-axis. However, it's now rotating only this one. And the reason for that, of course, is that each node group is only affecting the z location. So the easiest way to fix this is to make 3 different versions of this node group. One for the x-axis, one for the y-axis, and one for the z-axis. So let's first make the one for the z-axis. That's going to be the one that is named 0. So let's click on this 6 over here to make a duplicate. And then if we do n, we can go into node and we can make this z-axis. And the z-axis should also affect 2. So we can actually take this node group, Control X, take this one, Shift D it over here and set it on 2. That's the easiest way to do it. This we also want to do for the x and y axis. So let's take number 1, which should be the y axis. So let's click on this 4 to separate it from the rest. And let's go into it and let's change this to y and to y. And then you will see, oh yeah, that doesn't really work. Oh, I forgot one thing. We also need to change this one to the y axis, of course. Otherwise it still wants to do it over the z axis. So if you rotate it now, then you will see it works perfectly fine. So this one we can also rename to y-axis. The y-axis should also affect the third one. So we can take this one, Control X to remove it, and let's do Shift D over here, side index on 3, and then that works perfectly fine. Last one is going to be for the X-axis, and that's going to be 4 and 5. So let's take this one, click on the 2, and let's go into it, and let's make this X and X, and let's take this one and make it X2, and let's go out of it and let's rename this to X-axis. And then let's do the same thing for this one. So let's do Control X to remove it, Shift D it over here, and let's make this 5. And then let's check out our Rubik's Cube. It should work perfectly fine. If we rotate any side, then you will see it works in a perfect way. However, if it's gray like this, it's not really a Rubik's Cube, right? So let's actually apply the colors to this Rubik's Cube. So for the colors, we of course want to go into material preview mode so that we can actually see the colors. And the easiest way to apply those Rubik's Cube colors to it is by taking the original instance cube that we have over here. So if I disconnect that for now and I do Alt Shift click, and then we have the original cube. Let's see if I move this all the way over here. We want to assign a color to each side of this cube. And the most straightforward way to do this is just by doing a store named attribute, which we set on color. And of course we want to set this on face because we want to color the faces and not the points. And let's name this attribute call from color. Okay, now that we have this attribute color, let's actually see if we can use this into the shader editor. So let's go over here into the shader editor and let's name this material the color material. And to get this attribute over here, we can do an attribute node, which we name call. And if we make this value red now, we can put it over here. Then you see nothing is happening yet. That's because we have to assign this color value onto the cube in geometry nodes with a set material node set to color. Then you see everything becomes red. However, we only want that one face becomes red. So what we want to do is an index node, and we want to say if the index is a certain number, then it should make it red. So if we do a compare node, which we set on integer and we make it equal, we can say if the integer is equal, make it red. And now you see this one is red. This we basically want to do for every color. So for once, let's do that in a manual way. So let's duplicate these two nodes 6 times by doing that like this and like this and like this and like so. And then let's also connect the index with all the compare nodes like so and like so and like so. If you want to have a little bit more overview in this index, you can hold down Shift and right click and put it over here to make joins. It's a bit easier than you can do it like this. So something like this and like that and like so. A bit more overview. Let's make different colors, right? So let's make this one yellow. Let's make this one green. Let's make this one blue, for example. I know that one is white. So let's make it white, and let's make another one orange like this. However, we of course also need to connect them, otherwise it's never going to work. So let's connect them like so and like so. And of course we also need to set the numbers over here to 1 and 2 and 3 and 4 and 5. And then you will see we have the colors of a Rubik's Cube. I'm not really sure if this is the right order of the colors, but if it's not, then you can just change the order of the numbers over here. Okay, let's see what that looks like if we put it back into the instance over here and we put it back over here. Then you see, okay, that looks good. Oh, and if it doesn't look good, if it's still white for you, make sure that you're pressing play again so that it can reset the simulation. Okay, then you will see that it works really perfect with all the colors, etc. Yeah, cool. Let's set all these values back to 0 so that it's their starting position, of course. If we press play, you see it's back. Okay, now we have this, but this Rubik's Cube is already solved. However, in real life, you would never really have a Rubik's Cube that is already solved, unless you have already solved this, of course. But let's say we want to have a cube that is not solved yet. So basically what I'm saying is we want to give this cube a random starting position. And we're going to do that also in a very straightforward way. So if we make more space between all of this and the simulation zone, what we can do is disconnect this for now. Take all these, Shift D them over here, and we want to use a repeat zone to make iterations in order to get a random starting position. So if you connect that like so and like so and like so, okay, we want that each iteration, each part of the cube gets rotated. So basically what you could say is we take this iteration and we put it into the rotation socket. However, if you then put the iterations up, you see it's the same as before. But what we want is that each iteration, it rotates 8 units so that it's always connecting with this. So in order to do this, we want to do a math node and we want to multiply this value with 8, and then you will see it's rotating the entire thing each time. Okay, this we basically want to do for every single one. So if we connect it like this and like so and like so and like so, and then the last one like this, then again we can make joints, of course, to make it a little bit more of an overview, like this and like so and like so and like so. And then you will see if you set the iterations up, you will see we're getting quite a random result. And yeah, good luck with solving this. I'm not going to solve this because I am horrible at solving Rubik's cubes. I'm only good at creating them in Blender. Oh, and very quickly, if you want to make this cube a little bit better with like thicker black edges, then you can go over here and move all of this a bit over here. And what we want to do is an extrude mesh node, and we want to set the offset on 0. And then if you do a scale elements node, and this thing we want to scale is the top part of the extrude mesh, then if you scale this, you will see you're getting things like so, which is good. And then if you do another extrude mesh node, and this time extrude it inside, but only the top part of the previous extrude mesh, then you are getting things like this. And then in order to make this part black, let's do another set material node. And let's also go over here and let's create a new material slot. And let's click on new to make this the black material. We want to make this one the black material. So let's make this black. And the color should only be the top part of this extrude mesh. So if you do that like this, now you will see you have a perfect looking Rubik's Cube. And also if you want to bevel the edges over here, I just recommend to add in a bevel modifier. And then you will see that doesn't do anything because these cubes are still instances. So in the beginning, we need to do a realize instances node, and then that does something. If you make the iterations higher, then you can put it a little bit smaller like so. And yeah, then you see that still works perfectly fine. You can still rotate it like this and it looks pretty cool, to be honest. And that already brings us to the end of this tutorial. However, I can completely understand if you're thinking, what is the actual use case or reason to create a Rubik's Cube in Blender? The biggest reason that I can give you is that sometimes it's good to create very random stuff in Blender because it opens up for new creative ways of using geometry nodes. But I hope you liked this video again, and if you did, please give this video a thumbs up, comment down below if you have any questions, and if you don't want to miss out on any future videos, I recommend subscribing to the channel. And with that being said, be sure to check out the big notebook by going into the link in the description to get 25% off your purchase. And with that being said, I see you in the next one.